Now let we see the example problem. Find the moment of inertia about the centroidal x-axis and y-y axis of the angle section shown in figure. Solution. First of all, let us find the center of gravity of the section. As the section is not symmetrical about any sections, therefore we have to find out the value of x bar and y bar for the angle sections. Now split up the section into two rectangle, section 1 and section 2 as shown in figure. The moment of inertia about centroidal x-axis is for rectangle 1, so area 1 is equal to breadth into height for section 1. So breadth of the section is equal to 20 mm and height of the section 1 is equal to 100 mm. Therefore, area 1 is equal to 2000 mm square. The y1, the distance along the y-axis, centroid of distance y1 is equal to 100 divided by 2 is equal to 50 mm for rectangle section 2. So area 2 is equal to 60 mm. Therefore 18 minus 20 mm is equal to breadth of the section 2 and the height of the section 2 is equal to 20 mm. Therefore area of the section 2 is equal to 1200 mm square. So y2 is equal to centroid of the section 2, y2 is equal to 20 divided by 2 is equal to 10 mm. We know that distance between the center of gravity of the section and the bottom face. So y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2 is equal to a1 is equal to 2000 into y1 is equal to 50 plus a2 is equal to 1200 into y2 is equal to 10 divided by a1 is equal to 2000 plus a2 is equal to 1200. Therefore, so y bar is equal to 35 mm. We know that moment of inertia of a rectangle section 1 about an axis through its center of gravity and parallel to x-axis axis. Therefore, Ig1 is equal to bh cube divided by 12. So breadth of the section 1 is equal to 20 mm and the height of the section 1 is equal to 100. So 20 into 100 cube divided by 12 is equal to 1.667 into 10 to the power of 6 mm power 4. Center of gravity of rectangle section 1 from x-axis axis. So h1 is equal to so y1 minus y bar. So y1 is equal to 50 minus y bar is equal to 35 is equal to 15 mm. Moment of inertia of rectangle section 1 about x-axis axis is equal to Ig1 plus a into h1 square. So Ig1 is equal to 1.667 into 10 to the power of 6 plus area of 1 is equal to 2000 into h1 square is equal to 15 square. Therefore is equal to 2.117 into 10 to the power of 6 mm power 4. Similarly, moment of inertia of a rectangle 2 about an axis through its center of gravity and parallel to x-axis axis. So Ig2 is equal to bh cube divided by 12. So b for rectangle section 2 is equal to 60 mm and h for rectangle section 20. Therefore is equal to the value of Ig2 is equal to 0.04 into 10 to the power of 6 mm power 4. The distance of center of gravity of the rectangle section 2 from x-axis axis h2 is equal to y bar minus y2. So y bar is equal to 35 minus y2 is equal to 10 is equal to 25 mm. Moment of inertia of rectangle section 2 about x-axis axis is equal to Ig2 plus area 2 into h2 square is equal to 0.04 into 10 to the power of 6 plus, so area is equal to 1200 into h2 square is equal to 25 square is equal to 0.79 into 10 to the power of 6 mm power 4. Now moment of inertia of whole section about x-axis axis. So Ixx is equal to Ig1 plus Ig2. So Ig1 is equal to 2.117 10 to the power of 6 plus Ig2 is equal to 0.79 in 10 to the power of 6 is equal to 2.907 10 to the power of 6 mm power 4. Momenta inertia about centroidal YY axis for rectangle 1. So area 1 for rectangle is equal to breadth into height. So breadth of the rectangle 2 is equal to 60 mm and the height of the rectangle is equal to 20 mm. So for rectangle, so rectangle of section 1, B1 breadth is equal to 20 mm and height of the section 1 is equal to 100 mm. Therefore area 1 is equal to 2000 mm square. So x1 is equal to, along the x-axis, the centroid of x-axis, so 20 divided by 2 is equal to 10 mm. For rectangle 2, so area 2 is equal to section of breadth into h. So breadth is equal to 60 mm and h is equal to 20 mm. Therefore area 2 is equal to 1200 mm square. So x2 is equal to centroid of x-axis along the section x-axis on the section 2 is equal to 20 plus 60 divided by 2 is equal to 50 mm. The distance between the center of gravity of the section and the left face, so x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2 is equal to x bar is equal to 25 mm. We know that moment of inertia of rectangle section 1 about an axis through its center of gravity and parallel to y axis. So Ig1 is equal to h b cube divided by 12. H is equal to 100 mm for section 1, so breadth is equal to 20 mm. So h b cube divided by 12 is equal to 0.067 10 to the power of 6 mm power 4. Distance of center of gravity of the rectangle section 1 from y axis is equal to h1 is equal to x bar minus x1 is equal to x bar is equal to 25 mm minus x1 is equal to 10 mm is equal to 15 mm. Moment of inertia of rectangle section 1 about y axis is equal to Ig1 plus a1 h1 square is equal to 0.067 into 10 to the power of 6 plus, so area is equal to 2000 into h1 square is equal to 15 square is equal to 0.517 into 10 to the power of 6 mm power 4. Similarly, moment of inertia of rectangle section 2 about an axis through its center of gravity and parallel to y axis. Ig2 is equal to h b cube divided by 12. H for rectangle section 2 is equal to 20 mm. So breadth is equal to 60 mm. So 20 into 60 over cube divided by 12 is equal to 0.36 10 to the power of 6 mm power 4. And the distance of center of gravity of rectangle section 2 from y axis, h2 is equal to x2 minus x bar, so 50 minus 25 is equal to 25 mm. Moment of inertia of rectangle section 2 about y axis is equal to Ig2 plus a2 h2 square is equal to 0.36 into 10 to the power of 6 plus 1200 into 25 square is equal to 1.11 into 10 to the power of 6 mm power 4. Now moment of inertia of whole section about y axis is equal to Iyy is equal to Ig1 plus Ig2. So Ig1 is equal to 0.517 into 10 to the power of 6 plus Ig2 is equal to 1.11 into 10 to the power of 6 is equal to 1.627 into 10 to the power of 6 mm power 4. The polar moment of inertia is equal to Ixx plus Iyy. Next, the example problem 2. Find the central of an unequal angle section 100 mm into 80 mm into 20 mm as shown in figure. Solution: as the section is not symmetrical about any axis, therefore we have to find out the value of x bar and y bar for the angle sections. Now we split up the section into two rectangles as shown in figure. For rectangle 1, area 1 is equal to breadth and height. So breadth is equal to 20 mm and height is equal to 100 mm is equal to 2000 mm square. So x1 along the x-axis, the centroid of x1 is equal to the 20 divided by 2 is equal to 10 mm. Along the y-axis, centroid of y1 is equal to 100 divided by 2 is equal to 50 mm. For rectangle 2, area is equal to 60 mm, therefore 80 minus 20 is equal to 60 mm. So breadth and h, the height of the rectangle 2, section 2 is equal to 20 mm, therefore area 2 is equal to 1200 mm square. So x2 along the x-axis, the centroid of x2 is equal to the 20 plus 60 divided by 2 is equal to 50 mm. Along the y-axis, y2, centroid of y2 is equal to 20 divided by 2 is equal to 10 mm. The distance between center of gravity of the section and the left face x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. So a1 is equal to 2000 into x1 is equal to 10 plus a2 is equal to 1200 into x2 is equal to 50 divided by, so a1 is equal to 2000 plus a2 is equal to 1200 is equal to 25 mm. The distance, similarly, the distance between center of gravity of the section and the bottom face y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2 is equal to 2000 into 50 plus 1200 into 10 divided by 2000 plus 1200 is equal to 35 mm. Thank you.